Hello aviators, welcome back to my channel Skybreakers. Thanks for watching my channel. Please subscribe so you can watch my regular uploading videos. In this video, I would like to explain continuation of Airbus 320 pneumatic system. Normally, pneumatic systems are fitted in most of the modern aircraft. The high pressure air using for the pneumatic system to operate. The high pressure air getting sourced from engine number 1 and engine number 2, auxiliary power unit, that is APU, and external high pressure ground power unit. In this, important point is the priority. We have getting high pressure air from 3 sources, that is priority sequence. First one is auxiliary power unit, second one is ground connection, last one is engine. That is, suppose engine is supplying high pressure air to pneumatic system. Now APU started between. Then engine will stop supply bleed air to the system and APU will start continue supply high pressure air to the systems. In this point is very important. In pneumatic, high pressure air supply to various systems, that is air conditioning on the aircraft while starting the engine. Pneumatic system use bleed air for anti-icing in APU, wing and pylon. Next one is water to pressurized. Hydraulic reservoir pressurization in our A320 aircrafts has 3 hydraulic reservoir, that is green, blue, yellow reservoir. Reservoirs are pressurized using bleed air. Next one is cargo compartment and fuel tank inerting system heating. These two are option. In Airbus 320, most of the systems controlled and monitored by the computers. Even in pneumatic system also controlled and monitored by BMC, that is bleed monitoring computer. Normally the function of this computer is to control and monitor air pressure, air temperature, valve position, leak detections, and this all information given to ECAM, that is electronic centralized aircraft monitoring, and CFDS, that is centralized fault display system. Total 2 BMC. In normal operation both will active independently and both are interconnected. Suppose one BMC fails, other ally one take care of most of the functions but not everything. Here you can see this is the BMC1. BMC1 will take care of this pylon and left wing as well as APU. BMC2 will take care of pylon and right wing. Now we'll look into the schematic diagram of A320 pneumatic systems. In normal operation, pneumatic system engine number 1 and engine number 2 will operate independently. Here you can see I have given the example here, engine number 1. In normal operation, intermediate pressure compressor will supply bleed air to entire the pneumatic system. In case low RPM or less power, intermediate pressure is not sufficient to supply the bleed air to system. So an HP compressor, that is high pressure compressor, will supply bleed air to the system. This is the bleed valve. I will explain in other slides. And engine 1 starter, overpressure valve. Next is pre-cooler. Pre-cooler output air temperature approximately 200 degree centigrade normally. When high RPM or air which is coming from the engine out, that approximately 300 to 400 degree centigrade. This air we cannot directly supply to the other system. It may cause us fire or overheating. So need to reduce the temperature using the fan air from the engine. Next you can see here the ground air supply. This arrow is non-return valve. the air can supply towards to here, and the AP also you can see here non-return valve, and as well as like compressor, IP compressor also you can see non-return valve. Here AP bleed air valve, this is the cross bleed air valve. This is a very important. It separating the and engine number 1 and engine number 2 bleed. In normal operation, engine number 1 will supply these all systems and engine number 2 will supply these all system. When APU it's come alive, and this cross bleed valve will be open, will supply both system. The bleed air valve which is there on the engine number 1 and as well as engine number 2 will close. Here you can see HP valve open and bleed air supplying to the system, and this is HP valve closed and IP is supplying to the pneumatic system. These points are important and need to remember. Engine. Air bleed fed from IP and HP compressor stage. Normally bleed air taken from IP stage. If insufficient pressure from the IP stage, then HP stage will supply bleed air to the system. Next is bleed system. Pneumatically operated and controlled electrically by associated BMC. That is, we have two BMC, BMC1 and BMC2. Bleed valve acts as a shut-off valve or pressure regulating valve. Cross bleed valve, already I have showed you, permits there the interconnections or isolation. Next is pre-cooler. It is an air-to-air heat exchanger that uses the cooling air bleed from the engine fan to regulate the temperature approximately 200 degrees centigrade. Next one is APU. Air from the APU available on ground and in flight. Normally in flight, approximately 23,000 feet will supply APU bleed air. APU bleed air supplies the pneumatic system if APU speed above and 95%, that is, they are talking about the compressor speed. Next is if APU bleed is open, then engine bleed valve will close, that is priority basis. Control and indications of pneumatic systems in overhead panel. I have already explained to you about overhead panel. If you would like to know about more, please go through it. In air conditioning panel, pneumatic system control and indications are given. Half below you can see here. Normal operations, all the lights are off. If any malfunctions, for example overheat, overpressure or leak detections, the lights will illuminate. This is the engine 1 bleed air. The fault light and as well as off is given here. This is a push button, and APU bleed, the push button. This is the cross bleed valve rotary switch, and 3 position is given: shut, auto and open. In normal operations we need to put it in the auto positions. And next one is engine 2 fault and off push button. The last one is ECAM bleed page, and you can monitor from the cockpit. And this is a schematic for the pneumatic systems, and this is engine number 1 and engine number 2. And engine number 1, it's given here is intermediate pressure and HP pressure, and as well as this is the bleed air valve, and this is the ground connections, APU. This one is the cross bleed valve, and this is engine number 2. So it's supplying to the systems. It's normally, if you see in this diagram, and the APU is supplying to the entire the systems, and here the bleed valve of engine number 1, bleed valve for engine number 2 is closed. So when it's closed, normally you can see on the ECAM, then the digit which is given here 1 and 2 will be in amber in color. Hope you got basic idea about pneumatic systems. If you have any doubt about these systems for preparing exam, I can assist you. Whatever I explained here, do not recommend it to use in your airline. For that you need to refer your company FCOM or FCTM or QRH. We'll see you in another video. Thanks for watching. If you like this video, do not forget to press like button, subscribe to my YouTube channel so you can watch my regular uploading video. Comment below if you have any query. Happy landing. Thank you.